Hi all, welcome to C Programming Fundamentals. In this video, we will see how to write a C program to find the roots of a quadratic equation. So before we start coding, we will see how a quadratic equation looks and how to find the roots. So if you see a quadratic equation which looks like ax square plus bx plus c equal to 0, where a, b and c are coefficients. And if you are given a quadratic equation like this, the roots of this can be found by using the formula x equal to minus b plus or minus square root of b square minus 4ac whole divided by 2a. So by using this particular formula, we will be finding the roots. But the only thing which we should take care is a should not be equal to 0, because if a is equal to 0, then when we divide this entire thing by 2a, it will become 0, right? So we will not be able to get the values. So in this, the term b square minus 4ac is known as the discriminant of the quadratic equation. So this discriminant tells the nature of the roots, that is, if the discriminant is greater than 0, then the roots are real and different. If the discriminant is equal to 0, then the roots are real and equal. And in the last case, if the discriminant is less than 0, then the roots are complex and different. So this is how we find the roots of a quadratic equation. We will see the formulas in detail. So if it is greater than 0, then the root 1 is calculated by using the formula minus b plus square root of b square minus 4ac divided by 2a, and root 2 is calculated by minus b minus square root of b square minus 4ac by 2a. And in next case, if it is equal to 0, that is if the discriminant or the determinant is equal to 0, then root 1 and root 2 are equal, and it is calculated by using minus b by 2a. And the last case, if the determinant is less than 0, then root 1 is calculated as minus b by 2a, that's the real part, and the imaginary part will be square root of minus b square minus 4ac by 2a, and for root 2 it is minus b by 2a minus the imaginary part, that is square root of minus b square minus 4ac by 2a. So these are the ways in which we will be calculating the roots of a quadratic equation. Next we will see how to code this. So we will switch to our terminal. Okay, to start off with, I will use my gedit command and I will give the name of this particular program as quadratic.c. As usual, to start this program, we have to use the hash include stdio.h. And in this program, since we are using square root to calculate, I need to also include math.h, and we will start with our main function. So in this program, I have 3 coefficients, so let me declare it as float a, b and c, and I have a discriminant value which I have to calculate, and I also have to calculate multiple roots, right? So I'll give one for root 1, another one for root 2 to store my roots, and also if required I can give two more variable for my real part and imaginary part, right? So I have specified all the variables and I have declared it, and next I'll start with my printf statement. So I'll ask with the user to enter the coefficients. So I'll give it as enter the coefficients slashing, right? So that's it. Let me ask it separately. So I'll ask it as enter the value for coefficient A. So this coefficient can be scanned as percentage %f ampersand A. Need to close my double quotes here, right? So once it is taken, as we have already discussed, this value of A should not be equal to 0, right? So maybe we can check the condition here itself, because rather than collecting all the other details from the user, B, C values, and again doing the calculation, here itself we can check whether the user has entered the value 0. If it is 0, then we can ask the user to re-enter it, or maybe we can come out of the program, right? So I'll check with the condition. I'll write an if statement. If A equal to 0, let me just do the indentation part. Sorry. So I'll give the indentation here. Okay, so if the user has entered 0, maybe I can give a printf statement like error coefficient A cannot be 0. Right? And if I can exit the program here itself, so I can give return 1 and exit or come out of the program here itself, right? Else we can go with the next part. So I can ask with the user to enter the value for coefficient B, enter the value for coefficient B. I can use the scanf to take it, percentage %f ampersand B. Also I can ask the user to enter the value for coefficient C. I can use a scanf, use a percentage %f ampersand C. So now I have collected all my things, right? So next we can calculate the discriminant. So discriminant equal to, so B square I can give it as B star B minus 4 star A star C, right? b square minus 4ac. If you want, we can print this value also, so that the user will get to know what's the discriminant value, right? So discriminant equal to, maybe I can use percentage point to f, use a slash in, and I can print this variable discriminant, right? So the user will be able to see what's the discriminant value once you have done this. Now we have to check for those three conditions, that is whether it is greater than 0, equal to 0, or less than 0. Okay, so we'll check with each of this. So first condition is if discriminant is greater than 0. So if it is greater than 0, then the equation has two real roots, right? So I can just print it, printf the equation has two distinct real roots. I can give it like this, I can print it so that the user will understand. Now I can go with the calculation of roots. So root 1 equal to, so our equation is minus b, first is plus, sqrt is used to calculate the square root, so I use square root of discriminant, that is b square minus 4ac is nothing but discriminant, so straight away I can give it as discriminant square root of discriminant whole divided by 2 star a, right? So my root 1 is calculated. Similarly I'll calculate for root 2 equal to minus b minus square root of discriminant whole divided by 2 star a. Now I can print both the roots. I can give printf root 1 equal to percentage point to f, can use a slash in, and I can print the root 1 value, that is whatever value is there in root 1. Similarly I can print the next one also, printf root 2 equal to percentage point to f slash n root 2, right? So this, I hope it gives all the conditions as well as the values which is applicable for the discriminant which is greater than 0. So where I'll be printing this message, the equation has two distinct, sorry there was a small spelling mistake here, okay, distinct real roots, root 1 and root 2 is calculated and it is printed. Okay, so once it is done, next I'll go with the else part. Else if discriminant is equal to 0, so if it is equal to 0, then it has a repeated root, that is root 1 and root 2 are equal, right? So same like earlier one, we can print it. So printf the equation has repeated real roots, slash in, closing double quotes, right? So here I can calculate root 1 equal to, so the equation here is minus b by 2a, so it is minus b divided by 2 slash a, and I can print the value here, that is root equal to percentage point to f slash n, that is root 1, right? So here for the condition which is equal to 0 also we have done. Next, else I need not mention if discriminant is less than 0, because we check for both this condition, greater than 0, equal to 0, then obviously else part it will be less than 0 itself. So else, so in this case it has complex roots, it is two complex roots, so I can give it as printf the equation has two complex roots. So I'll give it as slash n closing double quotes, right? So for this I have specified two variables here, that is real part and image part, right? So I can give real part equal to minus b divided by 2a, and for imaginary part, image part equal to, here it is square root of minus discriminant divided by 2a. Okay, so it is square root of minus discriminant divided by 2a, right? So once we get this, we can print both values. So I give it as printf root 1 equal to, so it has a real and imaginary part, so point 2f, this plus point, sorry, percentage point 2fi, that is for the imaginary part, right? And I have to give the variables, that is the real part and image part. Close it. So similarly I have to print for the next root. So only difference is you'll be having a minus here, okay, the negative value. So root 2 equal to percentage point 2f minus percentage point 2fi slash n, can give the variables, the real part and imaginary part. Closing of the else, since it's end of the program, I can give it as return 0 and closing this. Okay, so once again, if we will just have a look at it, said included stdio.h and math.h, since I am using square root here, that is sqrt built-in function. Int main, I have declared all my variables as float, a, b, c, discriminant, root 1, root 2, real part and image part. So first I am printing enter the coefficients, and again I am asking the user enter the value for the coefficient a, and I am giving a scanf statement here, that is for a, and there itself we are checking if a equal to 0, then I have to print an error message saying like coefficient a cannot be 0, and we are returning 1, that is I am coming out of the program. So user might have to again rerun the program. Okay, so if a user has entered any value other than 0, then it will ask for the value for coefficient b, that will be scanned up inside. Then again value for c, it is taken into c using scanf. Then I am calculating the discriminant b square minus 4ac, and I am printing the discriminant value here. Once it is done, then I'll check with the condition. If discriminant is greater than 0, then I'm printing the equation as two distinct real roots. Root 1 and root 2 is calculated. So root 1 is minus b plus sqrt of discriminant whole divided by 2a. Similarly, root 2 is equal to minus b minus square root of discriminant whole divided by 2a, and I am printing root 1 and root 2 values are printed. Checking with the next condition, else if discriminant equal to 0, then I'll print the equation has repeated real roots, and root 1 equal to minus b by 2a, and I'm printing the root value. Else, that is if discriminant is less than 0, I'll print the equation has two complex roots. The real part is calculated as minus b by 2a, and the imaginary part is calculated as square root of minus discriminant divided by 2a, and I am printing, so when I am printing root 1 equal to the real part plus the imaginary part, and root 2 is the real part minus the imaginary part. I am coming out of the else statement, return 0 and fine. Okay, so once it is done, we will compile and see. So I'll save and come out of this GCC. My program name is quadratic.c minus o quadratic. That's a new name I'm going to give. Okay, so here one thing which you have to remember is you have to use a flag called as minus lm. But okay, maybe before that I'll show you like how it works in a normal way. So when I going to compile this, you get an error, right? So this shows like undefined reference to SQRT. So to avoid this, what you have to do is we have to link the math library for the SQRT function. Okay, so to do that I have to add a flag called as minus lm here in the GCC. So GCC, my program name, that's a C program, minus o quadratic is for the new file. Here I have to give it as minus lm, right? That is to avoid this undefined reference to SQRT. So when I execute this, now you can see by using that lm flag, that is to link the math library for the SQRT function, you will not get any compilation error. Okay, now I can run it as dot slash quadratic, right? So my program is running. So it asks enter the coefficients, enter the value for coefficient a. So maybe I can try with the value 0. So when I am trying, it gives error, coefficient a cannot be 0. So it's working fine, right? Okay, once again I'll run. So it will ask for the value for coefficient, so maybe I'll give it as 1. It will ask for the coefficient b, I'll give it as 2, and for coefficient c it is asking the values, I'll give it as 5, right? So it is telling discriminant is minus 16. So since it is less than 0, it has two complex roots. So it is telling root 1 is minus 1 plus 2i, and root 2 is minus 1 minus 2i. Okay, so we will also check with other things. Okay, so I'll give a different value. So to enter the value of coefficient, I'll give it as 1, b I'll give it as 5, and c I'll give it as 6. So discriminant is 1, that is greater than 0. So it gives the equation has two distinct real roots. So root 1 is minus 2 and root 2 is minus 3. Okay, maybe we can check with the repeated root also. So for checking the repeated root, I'll run it once again. So coefficients I have to give, a is 1, b I'll give it as minus 4, c I'll give it as 4. So discriminant I am getting 0. So the equation has repeated real roots, right? So I'm getting the value. So all this conditions it is working. So the only thing which you have to remember is you have to make use of the math.h, because we are using the SQRT function. And one more thing is, when you are using GCC, we have to make sure like we are using this minus lm flag, so that the math library is linked for the SQRT function. Okay, so if you want to get the algorithm as well as flowchart of this particular program, you can take it from the description. Thank you.